Hi, today we'll discuss about powder metallurgy. One small topic in farming, metal farming. So powder metallurgy is also a manufacturing method where you can generate a product or can develop a product. So we know that in casting, what we do, casting is one of the manufacturing method where you can produce components by using molten metal. Like if I take the molten metal and heat it and pour in the casting cavity, and we will get the required shape. Similarly, powder metallurgy, instead of in powder metallurgy also is a similar method. The objective is to develop a component, and here the approach is different. So as we have discussed in casting, we use molten metal and we pour the molten metal into the cavity where we will get the casting which is similar to the which required shape. But here in powder metallurgy, what we do is we powder the material, and with that powders we compact the powder to get into desired shape and heat the powders. This is a powder metallurgy. This is the oldest technique which are using, especially this is used for producing cutting tools and especially symmetrical components. Complex shape components are not possible with the powder metallurgy. This actually used in 3000 before early 3000 BC. Oldest method. To develop a component. Using still people are using for few specific components like carbide cutting tools, using from early 3000 BC. So in early 20th century, powder metallurgy was used to produce copper coins and medallions, platinum ingots and tungsten wires, and primary material for light bulb filaments. After World War II, the period rapid technological development occurred, so which are basically primarily in automotive applications. The iron and steel replaced copper as dominant powder metallurgy material. So 1970 it emerged as commercialization of rapidly solidified and amorphous powders, and the development of powder metallurgical injection molded method technology. In 1990s, increase in the exponential growth, actually the manufacturing from this powder metallurgy, especially like tungsten filaments and carbide cutting tools. These are the major components which are developed by using powder metallurgy. Other areas powder metallurgy are using is household applications, recreation equipment, hand tools, hardware items, business machines, industrial motors, hydraulics. These are the where extensively they are using powder metallurgy. And aerospace also, now they are using advanced composites, electronic components, magnetic materials. So powder metallurgy objective is manufacturing a component from powders. So metal powders. Only metal powders are used. So basic steps in powder metallurgy. there are four basic steps. First one is making powders. Second step is blending the powders or mixing. Blending or mixing the powders. Compacting, third step. Compacting metal powders. Sintering, fourth step. Sintering. So these are the four steps which are used, to develop a manufacture a component by using powder metallurgy. So first step is powder making or making powders. So as we have discussed, powder metallurgy is developing a component by using powders. So for that your first step is to prepare powder. So there are different methods for preparing powder. These methods we use based upon the requirement. Like suppose if the hard material, then we go for different one method, and if it is soft material we go for different normal method like grinding. If it is hard material we go for the atomization, different methods. So first method is atomization. So atomization is one of the most widely used for hard materials. Atomization, metal powders are prepared from molten metal by using high speed ideal gas or water jet. So here it's the layout is like this. Keep the molten metal in one tub and keep it as one enclosure. So from here send the ideal gas. Generally preferable is ideal gas. Sometimes people use water also. So what happens is, you keep a hole on the for the tub, metal powder tub. So allow the molten metal to fall down. So up in 90 degrees, use a jet, ideal gas jet or water jet, and project on it such that the metal powders, it will create fine minute metal powders, right, collected. And this is the one of the best method which you can create, one of the best method to create metal powders for hard materials. So this is molten metal, and this one is ideal gas or jet. Why we use ideal gas is it won't react with metal, so that's a one advantage. Sometimes we use water also because ideal gas may be costly, that's one reason. So this is one of the simplest method. Another method is chemical reduction. So here we reduce the metal oxides with hydrogen, use a chemical, and with the help of chemical, especially oxides, you know that aluminum oxide will form these finite metal particles. So reduce metal oxides with hydrogen, reduce metal oxides with hydrogen. So it's a chemical reduction process, which is one of the method to prepare metal powders. And another method is electrolyte decomposition, chemical method. Electrolyte decomposition. So here electrolysis, we know, right? Electrolysis is one of the process where anode and cathode will be there. So in electrolyte decomposition, powder deposits at anode and cathode. So metal powder deposits at cathode, it is a chemical reaction, it is a electrolysis process. We are not anyway entirely discussing the entire process, because it's the electrolysis, we know that anode and cathode will be there. You can keep both anode and cathode as a metal piece, or you can keep anode as a metal piece, because most of the material ions pass from anode to cathode compared to the cathode to anode. So if you want to create metal powder of steel, keep the steel rod as a anode, and you can keep steel rod as cathode also to get more metal powder. So next, another methods are normal methods for soft materials, like grinding is one method to prepare metal powder, milling is one method, these are the metals we use. So after getting metal powders, so powders ranging 1 mm to 1 micron is accepted. So because in any of this process, the powder size is not constant, each powder particle size. So because there are different size of particles, they are distributed sometime unevenly. So to distribute evenly the size of the particles, we use blending or mixing. Second step is blending. Different size and shape of metal particles combine or mix to get uniform mixture. So how you will get uniform mixture? Keep it in one shell and rotate it, mix uniformly, such that it will give the uniform mixture. After mixing, compacting is nothing but compressing, applying pressure. As the pressure increases, the density of the density decreases, porosity also decreases, contact area increases. Apply pressure to reduce porosity and to increase contact area between each particle. So we need to apply pressure such that the particles come close, such that porosity will come down, and it will get the uniform density will increase, and as well as contact area increases. Here the green strength is there. Compacting at room temperature is called green strength, and the strength of the part attained after compacting stage is called green strength. Strength of compacted metal powders, strength of the part obtained after compact stage is called green strength. Strength of the compacted metal powder attained after compacting. Part density of the solid part. So density of actual solid part. Apparent density of the compressed part. Density of the powdered particle after compression. The ratio of part density to apparent density is called compression ratio or compressibility. So part density compressibility will be more if it will be maximum equal to 1 or 0, lies between 0 to 1. Apparent density is always less than the part density, so it has to, the value is compressibility value is always greater than 1. If the powders are very fine, then it is greater than 10 or 10. If it is powders or particles are very big size, then density will be less, apparent density. So then the value is 3 or less than 3 or somewhere around 1 to 3. Next, last step is sintering. Sintering here, actually sintering also happens along with compression, compacting. Sintering is not heating compacted component. So heat the compacted component below the melting point of the material, that metal powder, such that you will get into metal will flow as like it will reach the flowing point, forms the solid. Heating compacted component below melting point of the metal. Heating compacted component below melting point of that powder, and then cool slowly. The final component whatever you get is the powder metallurgical component. So again you do some heat treatment process, depending upon the application, if you want to remove any stresses developed. That's what. So advantages. What are advantages of powder metallurgical component? It eliminates machining process, because we are not doing any machining. High production rates. Complex shapes cannot be produced, that is disadvantage, anyway we discuss. Wide variations in compositions are possible. Wide variation in compositions are possible. Scrap is eliminated. Limitations. High cost. Density variations produce property variations. Applications. So where do we need to generally we use here, and you can write few other points in limitations, like do not provide cross holes, and always try uniform cross sections only. So where do we use this powder metallurgy? This is used for manufacturing, cutting tools. Most of the cutting tools are manufactured by powder metallurgy. Tungsten filaments, cams, springs. So these are the applications of a powder metallurgy.